wallet. If you want to go use someone else's smart contract, you have to use an Ethereum wallet. We've set up a way that you can sort of combine the two and get the most out of both wallets. So I created this little application that helps you link a substrate and an Ethereum address together. And so you can see if I go to my wallet, into this one, I have 50 ACA, so the testnet tokens right here. Yeah, no problem. So I have 50 ACA right here, and in my MetaMask, you can see I'm connected to our testnet, but I have 0 ACA. So I can just go through, connect everything together, sign a message saying, hey, I want to link these two addresses together, enable it, and if you give it a few seconds, they're linked together, and if I check out my MetaMask and give it just a couple more seconds to load up, right away I can see that I have all my ACA, and these are completely connected. So I can do transactions, and I can send in my MetaMask, and that's going to reflect on my substrate wallet. And I can even do things like adding our like AUSD pre-deploy contract. I can import this token, it'll automatically detect everything, add it, and you'll see that I have my 5 AUSD in my wallet. And what's really cool about this is AUSD, our stablecoin, isn't a smart contract either. This is another on-chain native token, but using what we call pre-deploy contracts, we're able to expose functionality from the chain level into our EVM. So it's really the best of both worlds. We have this really high-performant, very customizable chain code, but to people who are building on EVM, they can just treat it like they treat anything else. So it doesn't really matter what you choose. And like I said before, I linked these two things together, but there's still a huge amount of people who are using substrate-based wallets. Maybe they're coming from other chains in the Polkadot ecosystem, or they just prefer the Polkadot wallets. We don't want to make people choose which one they have to do. We don't want to say, okay, well, if you want to use dApps on EVM, you have to go and get MetaMask and do everything like that. So another little small thing I have right here, it's a very simple smart contract I deploy to our testnet, a counter, and I can actually just switch between what kind of wallet I want to sign up. So say I want to increase the count on my substrate wallet, I can do that. It might take a couple seconds just because the Wi-Fi is not as good as it is back home. But you'll see in a few seconds that the count will go up. And I can later switch to Ethereum and then sign the same kinds of transactions with my Ethereum wallet. And just with a click of a button, I'm signing it with both wallets. And it's incredibly easy to do this integration. It doesn't require a huge code refactoring. It's just a Ethereum provider that we custom made that plugs right into Ether. I have a super question.
Yeah, I tried to mint AUSD, but it's asking me to connect to the substrate wallet.
What?
To mint Acala USD, I go to the app and it has no option to connect to MetaMask, only
right, so that's what I was getting at. So this dApp we made right here, this is only set up right now to work with our Polkadot addresses. But the whole point of what I was trying to get at is that when you connect up and link these two accounts, they're both connected. If you mint AUSD with a substrate thing, a substrate account that will show up in your MetaMask. If you use a dApp that interacts with these tokens with MetaMask, it'll show up in your substrate account. And that's just a huge amount of usability. You can take code that you may have deployed on another network, deploy it on Acala, and then access these two huge user bases, people who are like Polkadot native, people who are Ethereum native, and get all of the functionality out of that. So let's get into actually developing a smart contract. So we have full integration with all of the existing tools you might know about, right? If you're familiar with Solidity development, Hardhat, Truffle, Waffle. So it should be a very familiar building experience for everybody. I'm just using this template just so you don't have to watch me create a Hardhat project and configure everything. So we're just going to start from scratch right over here. So what we're going to be building in this workshop is an advanced escrow. So essentially the idea is you want to send somebody some money for some sort of service. You want it held in this escrow for a certain amount of time, and at a certain block, released to the person. And we're going to be utilizing two new features that we developed for the Acala EVM Plus. Our on-chain DEX. So you'll be able to interact with that chain level DEX that we made from Solidity, as well as our on-chain scheduler, which is really cool. So if you're familiar with current smart contract sort of patterns, whether it's an auction, an escrow, something like that, they'll set something up to happen at a certain block, and in your code you can say, okay, if someone tries to call this function before the block, just sort of revert, don't let them do it. But with the scheduler, you can actually say, tell your contract, hey, call this code at a future block. And so that's what this escrow is going to be doing. Once it gets to that block where it will release the funds, it will automatically send the funds to the other person. And then on top of that, using where the DEX comes in, is you might put AUSD into the escrow. But the person who's on the receiving end might say, I don't want to receive AUSD, I want to receive DOT, or I want to receive ETH or Bitcoin, or something else like that. And then the benefactor can decide what it is that they want to receive. So when it actually gets time for them to receive their tokens, the contract will automatically be doing a DEX swap in the backend. And again, the DEX and the scheduler, they're not built with Solidity, they're built with Rust and Substrate. So we're able to get that high level of customizability as well as efficiency. Okay. Let me just pull up any notes here. Okay, so the first thing we're going to want to do here is just rename the file to advanced escrow. And you might see me make a lot of typos here because I'm not very good at typing words like beneficiary. So if you see that, let me know. Okay, cool. So we're going to import some utility libraries here to help us out. So the first one we're going to want to import is the Acala network DEX contract interface. We're going to do that. We're going to do the Open Zeppelin ERC20. Because again, all of these tokens that we have, these native tokens, we expose them to the EVM using a ERC20 interface. So you interact with them like your ERC20s, they have the same things that you'd expect. So I mean, if you were, again, coming over to the Acala EVM and you have some code that you leverages these things, you can just treat them like they're in ERC20. There's nothing special, it's super easy to get integrated. Open Zeppelin. The next one we're going to import. I'll fix that in a sec. The next one we're going to import is our scheduler interface. And our address utility. I'm just going to keep talking. Okay, cool. And I'm going to take that one. All right, cool. All done. Okay, so I mean, this is pretty self-explanatory. Maybe the one that isn't is why I'm importing the address. So all of our pre-deploy contracts have static addresses in our EVM, so they're always going to be the same, whether it's on Kurura, which is our sort of canary test network, if you're familiar with how Polkadot does things with Kusama, Mandala, etc. And we want to have access to these in our smart contracts. So we're going to extend the address. Okay, cool. So the first thing we want to do is just set up, let our contract know that the DEX exists and that our scheduler exists. So we're going to do IDEX, DEX, that's just wanting to know where the DEX is, and we're going to do schedule. Okay, cool. Next up, we're going to define how many escrows there could be at once. So just for the sake of simplicity, we're going to make it so this contract only handles one escrow at a time. But we want to keep track of the number of escrows that have happened. And we're just going to do a mapping of the escrows. Okay, cool. Now let's just we're doing in there. We have to find the escrow structure. Escrow, and we're going to do the address of who initiated it, the address of the beneficiary, then I do have a spell check out on here, so that's probably relevant too. We're going to do the address of the token coming in. Another thing I mentioned is what we're doing here is you can pay any address, and you can receive any address, and they'll be figured out the DEX. So we want to know the address of the incoming tokenized, the egress token, and then the address of the egress token. And then how much do you want to be paying out in AUSD? The deadline, so the block that we want this to complete by, and if it is configured. Okay, cool. And then last little bit of setup is we're just going to define events. Say escrow updated, and we're going to do address of the address of the ingress token, the egress value, and with the period, so essentially how many blocks it will be until it is finished. Okay, cool. So with all that out of the way, let's set up our constructor. It's going to be really basic constructor. It's going to set a number of escrows to 0. To start out. And now let's get to the actual fun stuff. So again, the way we're setting this up is you want to be paying someone for some service. You initiate an escrow with this contract. You say how much AUSD value you want it to be. You give them any token. So if you want to be paid out, the person receiving might want to be paid out in DOT, but you want to just be in AUSD or BTC or ETH or anything like that. So we're going to do that, and then they can be, we have to find how long we want the escrow to go for, and the value of the token. So let's do that. The address of the beneficiary, the address of the ingress token, the amount of the ingress in AUSD, and then the period. And it's going to be public, return true if it is successful. Okay, cool. Just some more, good practice. There's things we want to do. First of which would be we can't start a new escrow if the current one is not complete yet. We want to make sure that the actual beneficiary is a correct address. We want to make sure that the amount of the tokens is 0. We want to make sure periods not 0, etc. So let's just set up some priorities. So number of escrows 0, or the escrows is the next one we want to do is swipe up. All right. So we want to make sure the beneficiary is not equal to 0. And we want to here. Then we want to make sure that the value of the ingress token is also valid. So ingress token is not equal to address 0. Okay, cool. Getting an error. What did I do wrong? Ah. And it should be. All right. So I'm just going to skip over the next few requires because I think you get the point. We wanted this contract to work properly, not have any major bugs. But let's just assume people are doing this correctly for the sake of time. And let's get into the more fun things. So we want, again, so the ingress token can be anything, but now what we want to do is we want to use our on-chain DEX to swap that to AUSD and store that in the contract. Because if somebody is putting in, let's say, a certain amount of DOT, a certain amount of anything else, and just staying there, that price will fluctuate, stablecoin stable, so we should swap that out pretty much right away. So what we're going to do is we're going to declare a new address for our token. And we're going to point it to our address.AUSD. And again, this is always static. It's always going to be the same. So we can just assume that it is going to be there. We don't have to do anything fancy. Okay. And now what we want to do is we want to just check the initial balance of the token for this smart contract, and then set up the DEX swap to swap the ingress token into AUSD to hold it. So we are going to get the initial value of AUSD. AUSD token dot balance of address this. I feel like I have a couple too many things. Yep. All right. And now we want to set up the path. So essentially the path in the DEX that we are going to take to swap from the ingress token to AUSD. So it's going to be an array memory of addresses. And we're going to set the initial token to be the ingress token. And we're going to set the output to be
AUSD. So again, don't need a 2 there. So we're just setting up the path that the DEX is going to take. We're telling it what tokens to be using to get where we need to be going. I remember this, but I'm trying to figure out what the solution was. If there's any Solidity experts out there who want to tell me what I need to change this to quickly, I'd appreciate that, because I remember doing it before, but now that I'm on stage, I'm forgetting. I just have to change this to something other than that to say that it is a 256. I think it might just be as simple as saying, this isn't the right way to do it, but that might sound familiar, I think. What? What am I trying to achieve? I'm just creating an array of 2 values. I'm just going to keep that for now, and I'll double check in a sec. But let's just keep going in terms of like the logic. So then what we want to do is we want to get the final value. I can put it in the square brackets. I thought I just tried that. What? Yeah. Like I have right now. I'll follow up with you in a little bit. I can double check the example in a sec. So we just want to get the final value to make sure the swap was actually successful. And then we're just going to so we want to make sure that the initial value and the final value are different, because we want to make sure the swap is actually successful. So initial balance is not equal to final balance. All right, cool. So ignoring this bit, which I'll fix later, I promise. We want to do another cool thing, which is actually schedule this call. Use the scheduler to schedule when this escrow should finish. So what we're going to do is we're using our on-chain scheduler to just basically say, hey, in the future, call this function to complete the escrow. So we're going to do that just by doing schedule call. We're going to do the address of where we want to call. So this address. I'm going to be putting in a lot of numbers here that you don't really have to worry about at this second. And the reason I say that is because we are in the process of just redoing this API a little bit to make it a little bit more user-friendly, but I will go over basically what's happening. The more interesting bit right here is this ABI.encode with signature. Essentially what we're doing is we're letting the scheduler know what to actually call on this address that we passed in over here. And we haven't created this function yet, but we'll get there in a sec. But it's going to be this complete escrow. So this does actually get me into another cool feature of our EVM, and that is things we're doing with storage. I'm sure a lot of people here who have done Solidity development have decided that they want to create their own ERC20, and they go on Ethereum, and they create Brettcoin, and they give themselves 1 billion Brettcoin, like that's awesome, and then they forget about it, never touch it again. Well, and that's cool, and it's really open like that, and that's awesome. But one thing a lot of people probably haven't thought about is that lives forever on chain, and that means people who are running node operators have to account for that storage. and it just isn't the most efficient thing in the world. So we have something called storage rent, and that's essentially saying if you're going to be deploying on the EVM, just like there are fees for doing transactions that are going to take a long time, there should be some sort of fee that is associated with taking up a lot of storage. And this also does get people to think more about storage and how to clean up the storage, because it's not so much a fee as it is sort of like a loan. So you'll lock up some ACA in our case to say, okay, I'm taking up all the storage for my smart contract. And then later, if you either clear the storage, do something in your smart contract, get rid of that storage, you'll get that ACA back. So, I mean, as a developer, it's not the most like amazing thing in the world to think about. It's another thing to think about, but I hope you can see that there is a benefit there to keeping things running as efficiently as possible. Our mentality was the EVM is great, but in what areas can we improve it, both from the user perspective, so things like the DEX, the schedule, and all of that, but also just from like the network perspective, what can be done to improve the entire process. Okay, cool. Any questions so far? No? Okay. Okay, cool. So we have the call to complete the escrow in the future, but now what we have to do is actually create that escrow struct that we made before. So we're going to create a new escrow. And we're just going to set up all of the different values on it. I'm missing an S. Oop. Okay, cool. So current escrow. I called it storage. I don't know why. It's autocomplete. I think this is supposed to be initiator. I probably misspelled it. Yeah. My typo add-on didn't catch that. So that's just going to be the sender, the beneficiary is going to be should just be the beneficiary. The ingress token is going to be the, I feel like I didn't name anything, but I thought I named it. The value in AUSD, so AUSD value equals AUSD value. And then it's actually just going to be what's based off of the swap, because there is a little bit of slippage there. So final AUSD balance minus initial AUSD balance. Okay, and then we want the deadline. And we just want to increase the number of escrows by 1. And then we'll omit the escrow update event. Finally, we're going to return true. Okay, so that's pretty long. Am I missing a field? I might be. What else did I have in there? Oh, made the period. It's called period. Perfect. All right. All right, cool. So if you're watching this and you're thinking this looks a lot like normal Solidity development, that's kind of the point. We are integrating something into existing workflows. You don't want to be changing how everyone does their code. You can basically just think of all the different things that we add as just sort of smart contracts. There are a lot more than that under the hood, but we just want people to understand that everything we're adding can be really easily integrated into your existing smart contracts. So if you're deployed right now on Ethereum and you have a smart contract that uses a stable coin and a DEX, you can very easily just port your contract over to Acala, swap out some addresses for AUSD and our DEX, and then just hit the ground running. Okay, cool. So the next thing we want to do is make it so that the beneficiary can set what the egress token is on the contract. So again, I can give any token to the contract, it converts to USD. The person who's receiving it can just use whatever they want to. So we're going to make a new function called set egress token, and we're going to set the address of the egress token. Public returns full. Another required, we want to make sure the person calling this is actually the person who can be receiving the token. So we're going to do escrows, one, the beneficiary equal to message.sender. And then all we want to do is set the token again. All right, simple enough. And last but not least, what we want to do is we want to set up this function that we created over here. So we already referenced it. This scheduled call is going to be calling the complete escrow in period number of blocks. So now we actually have to create the function for it to call. Function complete escrow. And this is going to take no arguments. Okay, cool. So we want to get the current escrow. Get the current escrow from storage. Require that the current escrow is completed. And then we want to require that the person calling this can be either the contract itself, so the contract when the scheduler calls it, or the person who set up the escrow in case they wanted to end it early. So message.sender is equal to the current escrow.initiator or address this. Okay, cool. So again, what we want to do now is that person has completed the escrow has finished, and we want to be paying it out. What we want to do is we want to convert the AUSD that's in the escrow into whatever token that the beneficiary wants to be receiving. So we're going to set up a new path. getting an error there again. I'll check that in a few minutes. So we want to start with AUSD because that is what's currently in the escrow, and we want the ending token to be whatever the beneficiary set, whether it's AUSD or whether they set something else. So we're gonna do current escrow dot egress token. And then one more required. What we want to do is just want to make sure that the swap is successful. So DEX dot swap with exact supply, path, the AUSD amount, and then the minimum. All right, and now let's get the final balance so we know how much to pay out. And then we're going to transfer it to the beneficiary. So we're going to transfer it to the beneficiary. And we're going to transfer the final balance minus the initial AUSD balance. For the initial balance. Did I not get that? Yes. This up here. We want to get the initial balance of the token. I feel like you're gonna answer. Nope. Very cool. Now let's get that final balance. Oh, I already did that. And we transferred it. Okay, cool. What am I missing? Then we want to do current escrow dot completed equals true. We want to omit the event. Okay, cool. So that's pretty much it. I cut a couple corners in terms of requires and double checking things, but I mean, I figure that's fine considering this is not a deployment that we're going to be making. I just want to be showing off the main things. So I hope that through this, you were able to get a good understanding of how easy it is to leverage these DeFi primitives, as we call them. So like to name a few of the other features of the chain that we have an on-chain oracle, which again, through Substrate, we're able to do certain things like transaction prioritization to make sure that these values are always getting onto chain, so that if there's a huge spike in usage, the oracle is actually updating the value and you don't have issues with any sort of smart contracts that leverage that. We have our scheduler so that you can schedule calls in advance to actually happen later. I can think of some really cool things to do with that. Like imagine making an auction contract where you say, I want to accept bids in any token as long as that is worth a certain amount of AUSD. So you can literally just say that once the auction goes live, figure out what the AUSD value is at that moment at the specific block, and then only be accepting bids that are at least that amount. We also have our entire AUSD protocol that you can use through the EVM if you want to be making contracts that utilize that. Our liquid staking protocol. There's a lot of really cool things you can do there. So because I was not super confident in my ability to sort of do this by memory, I do have a completed tutorial that I confirm does work. I don't remember what I called this. Oh. And what we're going to do is we're just going to deploy it. Again, this is just using hard hat. We successfully deployed it. And we can even make sure that it actually works by, I have to start this loop. I'll explain that in a sec. Yarn, I think it's user journey. And that should start running through everything like that. What I had to do right there was set up this loop script to go. And that's just that's one thing that we're working out. Essentially, our chain is still substrate even with the EVM. And one of the really cool things for development is something called instant sealing, which basically means that blocks are instantly sealed when they receive a transaction. So obviously that can be really useful for when you're testing things out. You don't have to be waiting for block times and things like that. Makes contract deployment a little bit weird because you go to deploy a contract, especially with the scheduler, where you're like, okay, I want to wait until a certain block, but it's waiting for more transactions. So essentially my loop is just pushing out some transactions to get the chain going. But I'm pretty sure we have a fix for that. I just didn't want to mess anything up for this workshop. So we see that we have the ingress token, we have the egress token, and it is just waiting for the target, which is 10 blocks from the start, to change the what the egress token is going to be. While this is running, does anybody have any questions? No? Okay. Yes.
Where is this code running on the blockchain? It's like a smart contract which is continuously monitoring. Because I was considering even cheating has deeper to integration. If there is a particular event is triggered, then this enforce contract. So where is this happening?
Where is the scheduler living? So the scheduler lives natively on Acala itself, and we basically just expose interactions with it through our precompiled smart contracts. So I'm not sure if I 100% understand your question, but basically the whole point is that it's running on the chain level, so super efficient, super fast, but it is you can interact with it as if it were a smart contract. So yeah, sorry, does that answer your question?
So there are two parts. So one is smart contract which has conditions. But if I want to let's say make a connect to a transaction, someone should do that action. I can't automate every 60 seconds to a game. So you have a condition, you have autonomous, and when that is met, it triggers that.
Gotcha. So you could do that. You could say, you can have the scheduler call a function that calls the scheduler. So you could imagine in our code over here, we had this in the initiate escrow, we called the scheduler. And now imagine if you had in complete escrow, another scheduler call was made. So maybe you wanted to be paying out somebody in every 100 blocks, pay out a little bit at a time. until it's done. What you would do is you would have another call to the scheduler in this that then waits and calls it again. But there are some things you have to think about there. So, I mean, no transactions are free. The contract itself needs to have some sort of balance to be paying for this. So you'd have to figure out something like that. You have to preload it somehow or work that into the tokenomics of your smart contract. But yeah, something like that is definitely possible. Whether it's the most efficient way to do it, I don't know. But I mean, the options are there, which they wouldn't be on Ethereum. All right, cool. So I mean, we see that it went through, and it worked. So the final dot amount was just under 4 more than the initial amount. Yeah. Does anyone? Yep. Another question.
So look, if I were to make all payments for the next year, I would need to obviously put all that into the contract.
Yeah. So you'd have to kind of work out how you would want to be paying for these scheduled calls. Another really great thing about our EVM is because all the transaction fees, again, are done at that chain level. Transaction fees are not huge. So it's not like you're loading up your contract with thousands of dollars just to be able to make like a few calls every single day. But you would have to figure out how you want to do that. Would it be front loading it? Would it be routinely requiring a small fee from the user who's interacting with it? But yeah, you do have to think about that when you're sort of making these things. Any other questions? Yeah. Someone else had a question? Yeah.
I was going to say, I think speaking to the storage constraints, like you mentioned before,
Mhm.
how do you know if you have a very heavy load or something? Like if this is a very heavy load as far as like taking up storage.
Right. That's a good question that I'd have to ask my team exactly how we're figuring those things out. I believe we have storage estimations and tools like that. And I mean, the worst case scenario is the deployment reverts because you didn't do that. But another thing is just like how you can set a gas limit when you're deploying a contract, you can also set a storage limit. So if you're deploying a contract and you're like, well, I don't want to take up more than this amount of storage, you can say, well, don't go over this amount. And I mean, another cool thing is we're doing a lot of really cool things with how transaction fees are settled and stuff like that. So again, transaction fees on EVM is something that we are improving upon, just even outside of the fact that we're running on a chain with a smaller token price than Ethereum. Yeah.
Yeah, so at the beginning you showed us a counter app and you
So going back to that counter that I had, I don't think that's it. So if you're familiar with creating smart contracts for Ethereum on the front end, you probably use something like Ethers or Free.js, and you probably have done the whole provider equals get provider blah blah blah. So one of the cool things that we did is we created a custom provider for our chain. So basically, this is written in React, but basically what you think about it is when I click Substrate, it's just switching which provider it's using. And when I click Ethereum, it's just switching to the other provider and then just doing the transactions. So that's another really cool thing. It's a small amount of code to be able to hit 2 huge user bases. People who are coming from other parts of the Polkadot ecosystem that don't necessarily have or want to use MetaMask, just interact with Acala, and people who are native to EVM-based chains who love MetaMask and just want to keep using that. And that's why there's no reason to pick between the two. I mean, I have 2 addresses that are even linked here in case there's a reason why I wanted to use both. Yeah. I mean, I think the whole point is that it's a really seamless user experience as well as being a very seamless developer experience. We know that the EVM is popular and people want to be developing on it. And instead of telling people to use something else, just bring everything in and sort of get even more out of it. That's the plus in EVM plus. Any other questions? Okay, Cool. So, I mean, that just about wraps things up. But before we go, I just want to remind everybody of our bounties. So we have 2 bounties ready, and I'm hoping that after this workshop, you kind of get the feel that this is something that's very doable. The first one is just to deploy a dApp onto Acala's testnet using the EVM Plus. So just like I just did with Hardhat, do it with any contract that you have, an existing one, one new one that you have a good idea using the scheduler or any of our other cool on-chain features. And then the other one is to develop a dApp that integrates AUSD into either an existing dApp or a brand new dApp. So again, you can access these things just like their ERC20 tokens. And I hope that through this tutorial, you've sort of got the gears turning in your head about all these really cool things that you could be doing within Acala's EVM. Any last questions? Okay, so I think that's going to be it from me, but we're going to be sticking around here for a little while to talk to anybody who has any questions, comments, things they want to say. Just a reminder, we have a lot of really cool merch over there. We still have some hats, which are a hot commodity, so I could recommend grabbing those if you can. And even some hoodies, so, you know, take them while they're here. Some pizza, and yeah, it's been really cool presenting here in front of all of you, and I hope you guys are a little bit more interested in building with us in the future. Thank you.
Did it, way to go. You got a lot of coders trying to keep up with you online. Yeah.
Hey guys, thanks for coming. Feel free to grab some Acala swag here. We have hoodies, hats, shirts, stickers. We also have pizza in the back. There's tons of it. So thank you guys for coming, and come say hi to us.
Sweet. Are you guys going to be shutting the street down then too?
Yeah.
All right. Yeah, you guys be like, yeah, whatever dinner is happy. Oh, really? I got titles there. Oh, probably. I like it. I don't know if there's not as many like curated or just people made playlists.